Hi, I'm Bob Tabor with www.learnvisualstudio.net. The fact that each entity in an Azure storage table can have different properties opens up some interesting possibilities. Now, I'm not sure how often I would actually use this in a real project. However, I can imagine a scenario where it might make sense to dynamically create objects at runtime with the intent of saving them into a table or retrieving table entities and treating them like you would any other static type, any other object that you instantiate. The exception being that the properties are not known until runtime. So in this module, what I want to do is show you two examples that you can download from online that cover these scenarios. How to create a dynamic object and save it and all of its dynamic properties into a table, how to retrieve entities out and dynamically create objects with all those properties that we can then display to an end user for some reason, okay? And that's exactly what we'll do. Now again, I'd like to point out that these are examples that are released by Microsoft. I'm just gonna walk you through them, how to get them set up, and talk about what their major features are, and then you can go off, download them yourself, play around with them, and learn a little bit more about how this all works. Okay, so two scenarios. Let's talk about the first scenario. It's very simple. I'm gonna create a dynamic object. I want to add dynamic properties to that dynamic object, and then I'm going to take that dynamic object and I'm going to save it into an Azure storage table. So as you can see on screen right now, I am at a URL where you can download this example, the C# version of this example, and I happen to already have downloaded it and I am working with it. Let's see, I think this is it. Yeah, that's it. Okay, so let's talk through what this example actually does. Actually, I'll run it. It's not very exciting to see in action. It just gives you a single line of feedback that it inserted an object successfully into table storage. What's interesting is how it went about doing that. So this should look familiar to you. This code here at the top, we're basically just creating a connection to a storage account, creating a table client, and then creating a connection to a table, and if that table doesn't exist, go ahead and create it. All right. What's really interesting is what comes next, is that first of all, we're going to create an object of type dynamic object table entity, but notice that we're using this dynamic keyword. Let's go ahead and take a look at this type. So I'm just right-clicking, I'm going to select go to definition, and we can see here that this dynamic object table entity derives from dynamic object and it implements iTable entity. So let's break that down. We'll go back here with this keyword in C# called dynamic, and essentially the dynamic keyword defines a type of system.object, which, as you know, is the base class for all data types in the .NET Framework common type system. However, unlike system.object, a dynamic type tells the compiler to chill out for a little while and don't be so static. In other words, we tell the compiler that we know what properties and methods that this object really has, even if we can't prove it statically at compile time. At runtime, trust us, we know what we're doing. Those properties will be there, they'll be filled up, and we'll be ready to go. So we're basically just saying we're going to create something dynamic. We're going to add properties to it dynamically. We're going to work with it. So don't worry that we don't already have a type defined that has all of these properties and methods, even though we don't have any in this example. And so this class that we're creating, it implements, or rather it inherits from dynamic objects. So this is a dynamic object and we plan on adding properties and potentially methods to it. But in addition to that, we wanted to implement iTable entity because that's how we get the serialization down to the Azure storage table. That's what forces us to implement properties like the partition key, the row key, the timestamp, and even the E tag. Now, the unfortunate thing about this example is that there's a lot of code in here that the creator left in here that is not being referenced at all. So you can pretty much ignore most of this. I think there's only one method here or one property that's being used outside of the ones that we talked about. But let's go back now that we have created a new instance of this dynamic object table entity. And we're passing in the partition key and then the row key into the constructor. Where's that? Yeah, that's this right here. Okay. Okay, now is when things get interesting. We have this entity, and we're going to add a name property to it. And we're going to set that name property equal to Patrick. And then we're going to create a message property. And then we're going to set that equal to hello. And then we're going to create an insert table operation passing in that entity, and then tell our connection to our table up in Azure to execute that operation. And then we get that insert successfully response. So let's take a look at what we got whenever we actually ran that. I'm in the Server Explorer. I've gone down to the Hero versus Robot storage account, and this should have created a table called short messages, and it did. And you can see here that we have an entity with these dynamic properties as well as the ones that we know are required. Recall that we sent in default and we used the time of day as the row key, and then we dynamically created two more properties, name and message. Let me, just for fun, show you how this works. I'm going to create another property, and you see how Visual Studio represents these in a blue font in IntelliSense, because it knows that, okay, we've already defined them in the previous two lines of code, so I'm going to go ahead and give you IntelliSense for these things, even though I'm not really sure what they are. Let's go ahead and add a hobbies equals reading and slip and slide. And now let's go ahead and we'll change this from Patrick to Pete, and we'll say goodbye instead this time. Let's run it now. We're going to get the same uninteresting result that it inserted successfully. The real interesting part of this, whoops, I already had this open. Let me refresh the results. And now you can see that I've dynamically added another property and inserted yet another entity into my table dynamically. All right, so that's the first example. And again, I guess I could see some instances where this might be interesting. Now we're going to do the corollary to that in this next scenario. So no, let's just close that current tab. Okay. So the next scenario that we want to talk about is that we're going to create something called a dynamic table entity, and this is a special object with special superpowers that is also dynamic. It allows us to work with properties dynamically, and it takes care of some of the heavy lifting for us as we're retrieving properties back out of that dynamic type. All right, if we didn't do that one, then we would have to do a lot of reflection over what we got back from the table entity, because we would just have a dynamic object of type system.object and we don't know what else it has. All right, so this will become clear in just a moment. So first of all, we're going to create instances of this dynamic type entity, and we're going to add some properties to two different entities. We'll save those into a table, and then we're going to display something to the user. The user will click a button, and then we're going to go out to Azure, retrieve an enumerable list of those dynamic table entities that we just inserted a moment ago, and then we're going to retrieve the properties and then display all the properties for each entity in a grid dynamically. And even we're going to be able to determine what their data type really is. So here again, take a look at this URL on screen. I found this as part of Microsoft's all-in-one code framework. If you're not familiar with this, you can click on that hyperlink. I installed the local client, and what this allows you to do, this is what it will look like. It just gives you like thousands and thousands of code samples, and they add, almost every day they add a new code sample to it. But say for example, I have a class that I want to find a code example for. I could search online, or I can search this all-in-one code framework. I find one that sounds interesting. I can read more about it. I can go out to this page out on the internet. I can download it. Now that I've downloaded it, I can open it up. I can see some other information about it. So, helpful little tool. If you're not familiar with that, let's close that down. All right. But assuming that you've downloaded this this code example, let's walk through it together. The most interesting thing happens here at the very top. Now this is going to be an ASP.NET Web Forms application. It's also implemented as a web role using cloud services. We have not talked about cloud services. Again, for the 100th time, we're not going to talk about cloud services because the recommendation for Microsoft now in 2015 is that you should use Azure websites, not cloud services, unless you have a really, really good reason not to. And we don't. But this example was written prior to Azure Websites' existence. And so what we'll have to do when we want to run it is we're going to have to take a little bit of a different tack than we did normally. But let's walk through this again. An ASP.NET web form in the page load event. What we're going to do is connect up to the storage account in the table, and then we're going to create a batch operation and insert entities from something called this user data list. Now, when we call out to user data list, it's actually going to call this this class user data, and it has a public property called user data list, and we're going to populate that user data list here in the constructor. So notice that we're setting user data list to a new list of dynamic table entity. As I hover my mouse cursor over that type, it implements iTableEntity. We talked about that in the previous example. That means that whatever we have here can be serialized and deserialized to and from Azure Table Storage. And it allows callers to directly access the property map of the entity. So an entity has a number of properties. Those properties will be represented as a properties collection on each instance of a dynamic table entity. And then we can just loop through all those properties and grab out their values for each key. And so what this does, it says here on the last part of this explanation, is that it eliminates the use of reflection for serialization and deserialization. So this would take care of us pulling out an entity from Azure Storage Tables, and we don't know what it is. We may not have a type defined in our application for that. And so we'd have to do reflection to see, all right, what properties do you have? What are the data types for those properties? What else do you have? And this class takes care of all of that for us, so we don't have to worry about it. But here we're going to create two instances of data table entity, create properties dynamically, and then we're going to add them to this list that'll actually then be inserted into an Azure table. Azure Storage Table. So you can see in this first case here, what I'm creating is a dictionary of name-value pairs. The name of the property and then the value of the property is of type entity property. And this entity property, it basically just allows you to pass anything to it. In this case, we're passing a string. This case, we're passing a boolean. This case, we're passing an integer, and it will figure out the data type for us, and will create the correct property mapping, and so that when we get ready to persist this, it can take care of all that logic for us. We set the partition key and the row key, and then we add it to our list. Notice that this second entry has an additional property called email, and we just pass it a string literal, and we give it partition key and the row key, and so on. So after we've called the batch operation insert, and executed the batch, we should now have two entities inside of an Azure Storage Table. Now, there's obviously going to be a click button on the web form. I haven't looked at it, the designer, but I know, having run this example, I know it's just a basic plain button. And what we're trying to do is grab the entities and then data bind them to a data table. And so a lot of the effort here, a lot of the code that's been written, like all this and a lot of this as well, is just going about dynamically creating that data table that will be displayed to the user. So unfortunately, some of that code obscures what I really think is the most important part of this example, which is retrieving the list, or the enumerable list of dynamic table entities. Okay, So here we're creating a new table query. We're not going to pass it any qualifiers. We're not going to try and filter it in any way. And then we call execute query, passing that in. Now notice that when we call execute query, that it is going to return an IEnumerable of dynamic table entity. Well, where did we set that? Well, we didn't. So whenever you create an instance of table query and you don't use the generic version of that class, what it's going to do is create a generic version of type dynamic table entity. And just to kind of contrast that to what we've done in like this table storage simple example that I've shown several times here, notice this time whenever we're creating a table query, we're passing in customer entity. We know the type, but in this new example, we don't know what the type is, so we don't give it the generic type. And so what we get back is one of these dynamic table entities, and we're going to let it figure out what the type is at runtime. All right, so then what happens next? Again, a lot of code to determine how we should display this on screen. But at some point, we're going to get we're going to get the table results. So that's going to give us back the results from the query on the table. And now what we can do is for each our way through those table results. Each item in the table results should be an entity, so we're going to iterate through the two entities. Now inside of each entity there should be a collection of properties, and we're going to for each our way through them. This KVP represents key value pair, and so we're going to grab the key and make that the column name. We're going to determine the type of the value associated with that key so that we can tell it to the column that we're going to use to display that data table. And then finally, as we want to display that value, we're going to retrieve the value, but we have to use one of the, I don't know if it's a helper method or just a way an accessor given the various types. So we're going to switch on the property type of the value. And if it's a Boolean value, we want it to represent true or false, not 0 or 1. If we are returning a date, then we want it represented as a nice friendly date, not just the number of ticks since the beginning of time. And if it's an integer value, well, we want it to look like an integer value. Okay, so now let's run the application, and this is where you're going to run into a little bit of a challenge. They set this up so that it uses the compute emulator. So just like there's a storage emulator, there's a compute emulator. The compute emulator allows you to run cloud services, web roles, and web workers on your local desktop for development purposes. Now, what it's suggested we do is that we close down Visual Studio and that we reopen, I'm going to close actually both of these, and that we reopen it in elevated permissions. So I'm going to right-click Visual Studio to get to the contextual menu in Windows 8.1. And I'm going to right-click the Visual Studio icon and select Run as Administrator. I'm going to get a user account control. Unfortunately, it's off on another screen. I'm running multiple screens. Just asking me, are you sure you want to allow this application to run with elevated privileges? And I'm going to go ahead and say yes. And then what I want to do is reopen that project, which I believe is that one there. Okay, and you can see that we're running in elevated privileges because you can see the word administrator next to the title in the title bar. So now we should be able to run the application. It should start up the compute emulator. It's doing that. And by the way, the compute emulator automatically starts up the storage emulator as well. Now, another unfortunate little bit is that it opened it up in Chrome, so we're going to have to run it in Chrome. Okay, so here's the little button. At this point, we should have two entities in our table because you remember in the page load, it called that little method, the constructor that would create them. Now we're just going to say, go ahead and retrieve them back and show them in a data table. Now I have a breakpoint here. Don't really need it, so I'm just click continue and continue. Well, let's go ahead and get rid of the breakpoint. And just continue out, and you can see how it works. It will display all of the properties for each of the entities, and we can see that the second item or the second entity had an extra property associated with it, the email address. Otherwise, everything else is rendered as we would expect. Notice because we were able to look at the type for a given column, it gave me like a check mark or a checkbox, which is an odd way to render the gender. I guess I have a gender versus I don't have a gender. I don't know what that's supposed to mean. So ideally, we would probably work on that little part of the application to make it a little bit more friendly and represent truly what those properties are. But again, they are coming in at dynamically, so we may not have that ability to do that. All right, but hopefully that makes sense. Hopefully now we've talked enough about how to work with dynamic types in relation to Azure Storage Tables that you have some level of comfort that you can create dynamic objects, or you can retrieve dynamic objects and work with them inside your application. All right, that's all I really wanted to accomplish in this module, and we'll move on to queues in the next module. We'll see you there. Thank you.